another video about drawing Lewis dots this time. Like I said, I'm really trying to make these short for you, but also give you enough detail so you can understand the concept. But you'll notice there's kind of a lot of writing on this slide, so I'd probably pause the video and get the writing down, or take a screenshot of it, or have the video a place that's available for you to have this pause while you're doing your homework. Alright, but we're going to be talking about drawing the Lewis dot structures now. So you remember the last video, the charge, we talked about Lewis dot structures. Now we're going to be trying to draw them. So, again, pause the video to write down these steps, or at least have the video up while you're doing your homework. I'm going to just go through these steps as we go through the problem. Alright, so we're going to be practicing drawing, going through each one of these steps. So your very first one is F2. Our first step is to count the number of valence electrons that we are going to have in our Lewis dot structure. So for this one, we're going to have F, and F is going to have 7 valence electrons. You get that from your periodic table, so have that periodic table out in front of you. So you have 7 valence electrons. There are 2 Fs, so it's going to be 7 times 2, and it's going to be 14 valence electrons. So when we draw our model at the end, we better have 14 valence electrons. So the next step says put the least electronegative one in the middle. There's only 2 atoms that are going to be bonded together, so you don't need to worry about putting anything in the middle. Step 3 says bond to the other elements. So we're going to have our F, and we're going to bond it to another F. Alright, so we've created a bond. You'll notice that a bond over here on the side, it says a bond equals 2 electrons. So we've used 2 electrons. So we can do 14 minus 2, and we know we have 12 other electrons that we need to put. So the other one says place in electrons to fill octets. So for F, we have 12 electrons. We have 2 different Fs. So you know each F is going to need 6 more electrons around it. And when we put in those 6 more electrons, we see that it fills up our octet perfectly. So we can always double check to make sure that we have the right number of electrons around each F. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Our Lewis dot structure works, and it is good. Alright, let's move to the one underneath it actually. Let's go to NH3. So we're going to have N, and it's going to have 5 valence electrons. We have H, and there's 1 valence electron for each H, times by 3, so it's going to be 3. So 3 plus 5, so there's going to be 8 valence electrons that we're going to have to account for in our bonds. So the step number 2 says put the least electronegative in the middle, or the one that can make the most amount of bonds. So N is going to be able to make the most amount of bonds. So we're going to put N in the middle. It's because N has that 5 valence electrons. H only has 1 valence electron, so it can only make 1 bond total. N could make a bunch of different bonds. So N's going to go in the middle. It's going to be bonded to 3 different H's. So we've already used up, we've done 3 bonds, and each of those is worth 2, so we've already used up 6 electrons. So A minus 6, we have just 2 electrons left. Luckily, to fill up our octet with N, we add the 2 electrons here, and it makes it a perfect octet for N. You can also always double check your work by making sure, this NH3, it had no positive or negative by it. And so if you do the formal charge for each of these, you'll notice that H has, 1 electron and 1 electron and 1 electron, so that all works out. N, normally N normally has 5 electrons. We do 5 minus 1, 2, 3, 4, 5, 5 minus 5, and that equals 0. So you notice there's no formal charge around this, so your Lewis dot structure worked out okay. Alright, let's go to our CO2. This is going to be a really tricky one. I'm just warning you before we even get started with it. Alright, so C has 4 valence electrons. O usually has 6. We times it by 2, so that equals 12. So total here we're going for 16 valence electrons. Now we need to start with our least electronegative one in the middle. So that's going to be C. Alright, and so C is going to bond with our O, and it's going to bond with our O on either side. Alright, so we've used up 4 valence electrons total, right? 2 for each of these bonds. So we can minus 4 here, and we get 12 left. So you might be thinking, we could put 6 valence electrons around each of the O's, alright? But let's see, if we did that, and we figured out our formal charge, we would see O normally wants 6 valence electrons, And so it would have 6 minus, it really has 1, 2, 3, 4, 5, 6, 7, 7. So it would have a negative 1 charge. This element up here does not have any charge on it, so you can't do that. So we cannot just put 6 electrons around there and be happy. You'll also notice that our C in the middle only has like 2 electrons around it, and C wants to have 4. So that doesn't work either. So we're going to have to do what's called a double bond. So our C and our O are going to have to be double bonded together. So you'll notice that gives our C now is going to have 4 electrons around it, which makes it happy. And now our oxygen, since now we've used 4 double bonds, we minus this by another 4, and we should get 8. Then now if we put our remaining 8 electrons around our oxygen, it makes it a octet, it makes it happy, and no charge on those. You can do the formal charge thing where we have oxygen, it has normally 6, this has 1, 2, 3, 4, 5, 6, so it has 0, so no formal charge, all the elements are happy and have the right amount of electrons. Alright, moving on to the last 2 examples, stay with me, I know it's long. Alright, CCl4, so count number of valence electrons, C has 4, Cl normally has 7, times it by 4, so that's going to be 28. So we have to do 28 plus our 4, which should be 32. So we're going to have to account for 32 electrons at the end. So we're going to start with our least electronegative one in the middle, and we're going to bond it to 4 different Cls. Alright, with those 4 different Cls, we've now used up, remember each line up here, each line is 2 electrons, so we've used up 4 different bonds, so 4 times 2, so we've used up 8, so we can minus 8 from this 32, and you should get 20, oops, sorry guys, so we should get about 24, right? So now we have 24 more electrons we have to fill. We know that Cl usually wants to have 7 electrons around it, so it's really great if we can give 6 to each of these Cls, it will be happy. So each Cl will get 6 extra dots around it. You could do your formal charge check to make sure that there's no formal charges on any of these. We can also count up the number of electrons to make sure that we did it right. So let's do that really fast. So we have 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32, perfect. So that is our drawing of CCl2, or CCl4. Alright, last one, hardest one, because you'll notice it has a charge on it. So we know we have to do our valence electrons first. So we have C, it normally has 4, H, normally has 1, we're timesing it by 3, so that's going to be 3, and then O normally has 6, and then we also notice it has a negative charge here. So negative charges means we're going to have that 1 extra electron. So if we add these up first, it would be 13, and we have to add 1 more electron to count for that negative, so it's going to actually have 14 valence electrons at the end. So again, start with your most or your least electronegative in the middle, or the one that can make the most number of bonds. So that's going to be C. C, we're going to bond it with 4 different H's. And we're going to bond it with our O. So let's count how many electrons we have left to use. So in each of these bonds, we have 2, 4, 6, 8. So we have 8 electrons that we've used. So 14 minus 8. So that should be 6 left. So we kind of only have one place to put them. Since H can't hold any more electrons, we have to put them around our O. So we put them around our O to finish it off. You can double count your electrons. So we have 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. We have 14 electrons. We know it has a negative charge. You can figure out which element that this goes on by doing oxygen. It normally has 6. Around it has 1, 2, 3, 4, 5, 6, 7. So 6 minus 7, so it has a negative 1 charge, so the oxygen gets the negative charge by it. Alright, so your homework is going to be giving you a bunch of these different ones. You're going to have to draw out those structures. You're also going to have to tell about polarity with them. So I'm going to do another video on polarity you can watch, or you can try to do it without watching the video. Up to you. Good luck on your homework. Let me know if you have any questions.